Welcome to another foss-north. I would like to start by thanking our gold sponsors, our silver sponsors, our base sponsors, and our partners from the community. So welcome back. Our next speaker, Alex, has also pre-recorded his talk, but will be available for Q&A. So let's watch the talk.
Thank you to foss-north for organizing this event and for the invitation. My name is Alexander Soto. My pronouns are he, him, his. I'm currently an expert in residence at Resilient Coders, and I'm the project lead at EI 2030. Below, you'll find my Twitter handle, Alex Soto Dev, email, our Zulip server, and website where you'll find the slides posted for this talk. A little history. EI 2030 started about a year ago amidst the COVID-19 pandemic, the transition to remote working, and the increased amount of time we spend on our digital devices. The goal of EI 2030 is to promote healthier computing practices, connecting people who are interested in learning, discussion, and facilitating the exchange of ideas and collaboration. We are EI 2030. We are a broad mix of hardware, productivity hackers, health tech enthusiasts, and gadget lovers. Our community is open to everyone, and we are steadily growing. I want to say a thank you to Wenting, Brody, Tom, Anjan, Matt, Manuel, Giovanni. Thank you for your time. Thank you for your contributions. Thank you for believing in a shared vision. This wouldn't be possible without you. We've recently have launched the community built Eink laptop project. We are building a proof of concept of an open source and open hardware e-ink laptop. As a community, we'll pull our resources, knowledge, and expertise into working groups. A working group focuses on a specific objective, it's time boxed, they document their process, and also shares resources and knowledge. So we have about 6 working groups. Drivers for e-ink displays, laptop chassis, non-emissive displays, and psychology and UX focus primarily with the objective on the community-built e-ink laptop project, while the low-power MCUs and paper term are exploring the possible use cases of an e-ink laptop. So before discussing the challenges of building an e-ink laptop, I'd like you to meet Archer. Archer is our proof of concept of an e-ink laptop. It will enable the early development of our EC firmware and the user software, test the chassis design ideas, verify the circuit design, and also enable future prototypes. So challenges building an e-ink laptop. So the first challenge is driving an e-ink display. There are about 2 parts when it comes to driving ink display. One is the display controller, or more specifically called the electrophoretic display controller, and also the waveforms. Typically, when you have a company like Dasung or Onyx, when they have a device, they specifically work with E-Ink Holdings. E-Ink Holdings provides support with the display controller to make it work with their board, and also provide these optimal waveforms. A lot of this information is proprietary, signed by like NDAs, and there's not really that much information that's available. So our approach is we're going to be creating open source alternatives to build our open hardware and open source e-ink laptop. We're building an open hardware electrophoretic display controller to drive the e-ink panels, and that will enable the creation of open source waveforms that can be used with different e-ink panels. It's going to be hosted on our GitHub account, and in time, beyond the e-ink laptop, what we hope to do is to create a database of open source waveforms that are compatible with a range of e-ink displays that can be used in different projects and devices. So this is a bit of our timeline that's been created by Wing Thing from the Driving E-Ink Displays working group. Sort of started working on the main board, on the chassis, and a lot of the work that's gone into it since late April to about late May and June, and we've just received our board that we're going to be testing. So again, thank you, Wenting. And here you can see the sort of the schematics for our main board and a bit more of a 3D rendering of it. The design files also can be found on our GitHub account. And a little bit more about the specifications of Archer. It's going to be using an IMX 7 Dual. Its main screen is a 10.3-inch E-Ink screen. It's going to have a subscreen that's going to be an LCD. And there's also some additional information here as well. And then going back, Caster is the code name for our open hardware EPDC that's going to be using an FPGA development board. It's going to be a M2E or 8 key slot, and it's going to provide one LVDS connector to connect to the EPD panels. And again, some more information about the FPGA development board, and also a block diagram that sort of shows the interaction between the main board, caster, and how that's going to work with the screen board itself. Our second challenge is the laptop chassis. So the E-Ink screens that fall in the range that could be used for an E-Ink laptop are between 10.3 and 13.3. These E-Ink screens use an aspect ratio of 4:3. Now, 4:3 sort of stopped being popular or not as much produced, so around 2008 or so. And because of that, it's difficult to find an original design manufacturer that has a laptop chassis with a 4:3 display aspect ratio. Typically, they're now 16:9 that's used for like media consumption and many other reasons. There are not many laptop chassis that are completely open and made with free open source software. So for Archer, we've decided to build our own chassis. And here you can see the picture I showed before, a bit of another close-up that you can see, and one of our initial prints with the keyboard. So we're going to be using an open source design or creating an open source design of a parametric laptop chassis using FreeCAD. And we've started looking at different possible laptop design. It is our hope that by using FreeCAD to design the laptop chassis, we can enable others to remix and adapt our design to their needs. The other challenge is the operating system and applications. There isn't an open source E-Ink first operating system, and there are few E-Ink optimized applications. There are some examples that we can draw inspiration from. There's a Modita OS that is based on FreeRTOS, an open source E-Ink mobile operating system. They have a developer preview where you can sign up. Light OS, it's based on the Android operating system project and uses a React Native app as the default launcher. Then there's also the Remarkable, which uses a custom Linux-based operating system to optimize for low latency with their tablets. Parts of it are available, the bootloader, the kernel, the SDK, but the UI is not publicly available. Onyx Box, or Onyx, and also Dasung. Similarly, proprietary, uses Android, but the UI itself is not really available. So this is sort of the pressing question is, what would a digital device look like that respects our attention, time, and health? The sort of the psychology and UX working group are researching how to create e-ink optimized applications and coming up with the different design principles, performing case studies on the possible psychological benefits of e-ink. And we're also exploring like Android, Fuchsia, and also a minimal Linux distribution. We're looking for software developers and UX UI designers who are interested in building e-ink applications. And then the other piece of the puzzle is sourcing the e-ink display. So e-ink, in order to be able to get an e-ink display, you need to be able to have some minimum order quantity. It's around, last we checked, the number is around 10,000. So, this gets back to our problem of the chicken and egg problem. There's a perceived lack of application and demand for e-ink displays or e-ink devices, and thus there's a lack of suppliers that are producing e-ink displays. We're looking at other non-emissive display technologies like DES, RLCD, E-ink, electrowetting, and the non-emissive displays working group. What we sort of decided is that we're going to be using a 10.3 inch E-ink panel from WaveShare. We're also looking to source different e-ink panels from other distributors like Good Display, and also exploring the use of display electronic slurry, DES, which comes from Good Display. And what's great about this option is that there's no MOQ. So we don't need to fulfill a large MOQ of like 10,000, for example. We can attain however many DS screens that we need. These are some examples of a DS screen and an E-ink screen as well. Uh, you can see that there's a bit of a higher contrast ratio, and we're pretty much in the early phases of exploring more using this DES screen. And then our last challenge is the manufacturing process. It's expensive. There's a cost that's involved when it comes to injection molding, the sourcing of parts, the keyboard, the hinges, fulfilling the minimum order quantities. There's very much a kind of domain specific knowledge that it comes to taking concept or idea, producing it, and then manufacturing it. Mistakes can happen, and it's also time consuming. So for our initial prototypes, we're going to be 3D printing them, the laptop chassis. And when it comes to producing a laptop at scale, we're going to have to, figure out the injection molding process and the whole manufacturing process. Right now we're also trying to explore crowdfunding options in the future. We're looking for more people with experience in the manufacturing process as well. So next steps. We want to learn from Archer and work on our second prototype that includes Caster, our open EPDC. We want to iterate on the open design of our laptop chassis and test it. We want to build E-ink optimized applications and identify people who are interested in contributing. Learn more about the manufacturing process. We're going to be applying to the 2021 Hackaday Prize, and we hope, fingers crossed, to do a crowdsourcing campaign in 2022. Again, so if any of these challenges or part of the project interests you, let's talk. Below you can find personal contact information and where to find the slides, and also our Zulip chat. And from EI 2030, we want to say thank you. Thank you for joining us.
Thank you, Alex. And now we're live. So I have a question / suggestion. There was a mentioning of the pocketbook e-readers and their OS and the software stack being open source. Is that something you're aware of?
I haven't looked into the pocketbook. I think when it comes to e-readers, there's a lot of different e-readers that have like an operating system, but that's one that I'll definitely look into. So I appreciate that.
Cool. No, and then there was a question here if there's an alternative hardware-wise to build a tablet instead, and then sort of have the user bring their own keyboard and so on. It would probably simplify parts of the production problems at least.
Yeah, we thought about this. Or I should say, so initially the idea started with this sort of like laptop, and then once we're reaching the laptop chassis part, I'm talking to Wen Ting. I'm like, Wen Ting, why don't we just make a tablet instead? And then he's like, yeah, we could go for a tablet. It would have simplified the chassis part. I think that this is something we want to explore a little bit later. I think some of the resistance I was met with a tablet, at least with some folks in the team, is that at least when some people, when you look at a tablet, you're thinking about using like a Wacom, like you want to give it a draw and touch. It sort of sets a different paradigm when it comes to how you're using the sort of the tablet. It would simplify things, but it also increases in levels, I would imagine, with engineering because of the small amount of space you have with a tablet. It's not something I would completely rule out, but I would imagine that by developing the OpenEPDC and also our main board, that could be repurposed, especially depending on the sort of SoC that we use later down the road.
So continuing down the hardware track, I mean, what's the key goal? Is it battery time and the longevity from that perspective, or is it the calmness of the display, or sort of? I used a Pebble. I appreciated that e-ink display, and it felt very vibrant. But I guess on a
Mhm.
bigger one, it's harder to drive the pixels that
Yeah.
quickly.
Yeah. So you're saying more or less the objective of the hardware, the goal of it overall,
The goal
or just a
of it overall, I'd say, so is what's why did you choose to go down the e-ink path and passive displays, so to speak?
So at least for me as a personal decision, I think that came about when I was both a teacher, when I was working for when I was both a teacher and also a graduate student. I was waking up about 5 or 6 in the morning, always in front of a computer, teaching 4 or 5 classes, going to grad school at like 5 p.m. and sitting in a 4 hour lecture, not getting home to about 11 p.m. or so, and just being completely exhausted. Some of that could be mitigated by taking breaks and not being in front of a computer screen as much. But I think part of it is also just a lot of our digital life revolves around these screens. So I think for me it was a personal motivation to use an ink screen. I know other people in the community, part of it has been in regards to some folks have had like ADHD and in regards to like attention. Some other folks are just into the idea of something like low powered, something that we can use for a very much a specific purpose. So my reason, somebody else's reason would be different, but I think that's kind of what's like uniting all of us here.
Yeah, and I mean that's a cool part about open source, that you can sort of join up and handle the the common problems together and then do different things with it.
And I think the other part to just like go around that is that the whole part about developing the EPDC and the waveforms that will allow other people in the future to use, to get the EPDC, implement their own waveforms, whatever e-ink panel they may have, and then repurpose it for any other device. So like I think by the development of this e-ink laptop, it's not just like the e-ink laptop, the EPDC being open hardware and also developing open source waveforms will enable more use of e-ink devices in other use cases.
Let me just see here. Now that was an answer to the question rather than another question. Some people just want to be able to work outside in the sun.
That all funny you should mention that. We have Matt. He the whole reason he's like, yeah, I just want to give publicity to this project. I just do like mountain climbing, and I just want to be able to take my laptop with me on the go. There's also that group which is actually kind of sizable. People who just want to be outside and
Yeah.
use screens.
But when it comes to OSs, you mentioned a whole range of it. Are have you decided on a path there? I mean, is it the RTOS or full Linux, and sort of that puts constraints on the hardware, I guess, when it comes to RAM and
Yeah, this is one area that we're still trying to figure out. That and also our our system with chip, what we're going to be using. When it comes to the operating system and which one to use, I think when I was going to operating system, I was just more given examples of different sort of e-ink operating systems that exist. I would imagine we first would want to use a sort of like a minimal Linux like distribution. But there are some problems with that when it comes to how the ink screen refreshes. There's a lot of applications that have like a dark screen mode. Yes, you can turn on like a light mode, but that's not exactly like optimized. I think there's more that could be done in that space. So I think we're mostly going to be focusing on creating like using an existing minimal Linux distribution and then trying to maybe optimize some applications. What that looks like yet, I'm not entirely sure. We're still actively trying to find more people who who's interested in this like challenge.
hint,
Um,
hint, nudge, nudge, I'm saying to everyone listening in. You actually answered my next question. It was about the reuse of software and where you see, but I guess that's something you're still exploring there, and what can be reused and what needs to be rewritten. Um,
mhm.
then I just had a personal reflection over the sourcing. Are have you considered collaborating with someone like Pine64, for instance, that are used to doing lower volume sort of consumer grade products?
I'd love to talk to Pine 64 if they'd be interested. We're actually, considering, for example, like using like the rock chips. I know rock chip like architecture. I know they're using it in a lot of their like products. So yeah, no, Pine 64 is one that'd be interested in talking about. I still think we're a bit in the earlier stages when it comes to like the MOQ. But we're getting there. Right now, we're towards our second prototype, and I think once we start getting the EPDC and making more choices when it comes to the SoC that we'll be using, would love to reach out to Pine 64. Actually, let me hold that. One of our team members has reached out to Pine 64 in the past, but I'm not remembering all the details of that conversation.
Oh, but you're talking. That's cool.
Yeah.
So that's the end of my question list. Let's give people a few more seconds if they want to add something more. There's lots of suggestions here. I'll leave it to you to read them. All
Okay.
possible games and fun. Is there any last words you want to leave us with?
No, I just want to say like thank you. I think in my slides I posted up our Zulip chat, and also with the slides that we posted. If any of this interests you, if you just want to follow along, please join us. We're hopefully trying to be a friendly community.
Super cool. Thank you for being here.
Thank you.